Hey, this is Anisha. You're watching CS Adda, so let's get started.
So guys, today we will learn what are the different steps of compilation of a C program. But before this, I recommend you should watch my previous tutorial of how to compile and run a C program in Linux operating system because it will give you a clearer knowledge. The link of that video is given in the description section, okay? So let's start. Now I have already created a file named ccompilation.c. So let's see what's inside it. Okay, so in the first line I have included the header file stdio.h because I will be using the printf function. Now in C we write comments like this. Okay, so these are comments. It has nothing to do with the execution, but I'm just writing it just to tell you guys what the meaning of this statement is. Okay, now in the next line I am defining a macro named pi and have given the value 3.14159. So whenever I am using this 3.14159 value, I can simply write pi over there and I don't have to write that entire value all over again. Okay, this is the use of the macro function. For more details, I will be giving another video for macro function, but here I won't say anything else about this. Then I have started the main function. Then I have printed the value of the pi. Okay, and then I have returned 0 and then ended the main function. So this is my program. Now our program has been saved and we will compile it. So the usual command cc -o, then the output file name that I'll give, which is C compilation. Then I will write something new, which is save temps, and then the C file. Okay, so what does this save temps does? When we compile a C program, it undergoes several steps which are usually not saved. Okay, now if we write save temps, here it will save each and every intermediate files that are created during the whole process. So let's see what happens. Now it has been compiled, and if we go to the directory, you see this is the C compilation.c file that has been created by me only while writing the program. This is the file that has been created by the compiler as the output. Okay, this is normal, we know this. Now there are 3 extra files that has been created by the compiler. What are these 3 extra files? These are the intermediate files that has been created by the compiler during the entire compilation process, and we have saved these files. So we can see these 3 extra files. Okay. So you see, when we execute the cc command, it not only calls the compiler but various other tools which are the preprocessor, compiler, assembler and linker. So the source code that we write in our C file, which is here the C compilation.c, is first passed to the preprocessor. The output of the preprocessor is then passed to the compiler, and then its output is passed to the assembler, and the output of the assembler is passed to the linker, and the linker finally outputs what we get as the executable file, which is here is the C compilation file. Each and every step performs some operation and converts the code from one format to another. Now let's see what are the formats. So first is preprocessor. A preprocessor is a program that accepts the source code and outputs an extended version of the source code to the compiler. What is this extended version? Let's see. The first intermediate file that was created is this ccompilation.i. Now let's see what's inside it. Gedit ccompilation.i. Here you can see a lot of new things are added to our program. What are these things? Let's go towards the end. You see the code that is written here is a bit different from what we actually wrote. Okay, so let's get back to the code we wrote. Here in the first line we wrote hash include stdio.h, but here it's missing. Why? Because the preprocessor has actually replaced it with the code that is written inside the file. Okay, so the above lines that are added over here are nothing but the code that is written inside the stdio.h header file. Okay, so one work of the preprocessor is to include the code that is written in the header file that we have included in our program. Okay, we will just write hash include then the header file name, and the preprocessor will automatically include the code in our program. Okay, now in the previous code, you see in the second line we wrote hash define pi 3.14159 and also use the value of the pi to print in the printf statement. Okay, but here this is also missing because the preprocessor has already replaced the name pi here with the value, so there is no need to write the definition of pi anymore. Okay, because the preprocessor has already replaced it with the value. Also, if you notice carefully, all the comment lines that we wrote in our program has been stripped off from here. So, the functions of a preprocessor are: number 1, inclusion of a file; number 2, expansion of macro; and number 3, removal of comment lines. Since this works before the compiler actually starts its processing, so it is called the preprocessor. And also in C, whatever we write after the hash sign, for example hash include, is called preprocessor directive, as it is processed by the preprocessor before the actual processing by the compiler starts. Okay. So we just saw that the preprocessor produces an extended source code which is then passed to the compiler. Now what is a compiler? Compiler is a program that converts a higher level language to a lower level language, which is in this case the C language to assembly language. Now what is an assembly language? It is a symbolic code which changes from one machine to another depending on the computer architecture. Now if you look at this diagram, you see C language is same for machine A and machine B, but the assembly language, which is a lower level language, is different in machine A than that of machine B only if the computer architecture of machine A is different from that of machine B, and the C compiler just converts this C language to assembly language. Now let's see an example in the code. The file created by the compiler is this one, ccompilation.s. It creates a .s file. Okay, so if we now open this file, you see our code has been converted to assembly language. Okay, so this is the assembly language. See, this main function is converted to assembly language. So we saw that the preprocessor takes in the .c file and produces the .i file, which is the extended source code. Then the compiler takes in the .i file and produces the .s file, which is the assembly code. Now this assembly code is passed to the assembler. What is an assembler? An assembler is a program that converts an assembly language to machine code. What is a machine code? Machine code is a program written in binary or hexadecimal format which computer can directly respond to. So the file created by the assembler is a .o file. Okay, it creates a file of extension .o. So it is an object file, and here it is ccompilation.o. Now if we open the file, viccompilation.o, you see it is a file written in binary format. Okay, so this is the machine code. Okay, so I showed you that our code has been converted to machine code. Now this is enough for the processor. Then why do we need linker? What is the function of a linker? So the linker links different libraries and other object files and combines them to form a single executable file. For example, there is a code which sets up the environment for passing command line arguments. So this code will be linked to our code by the linker. So this is the file that has been created by the compiler, okay, the ultimate file that we get after compilation. Now if we open this file, see, this is also written in binary format. Then what is the difference? Now if you check the size of the file, of the object file that has been created by the assembler, okay, which is C compilation.o. See, it is 136, text number is 136. Now if I check the size of the output file that we get after compilation, see, the text number increased to 1556. This is because the linker has linked other object files and other libraries to one executable file, okay. So these are the steps that our program passes through while it is being converted from C source code to machine code. For any doubts and queries, you can message me in Instagram or Facebook. Link of the page is given in the description. Hope you liked the video and please subscribe to my channel for more videos. Thanks for watching.